Okay, let us study photoelectric effect. Okay, it was given by H. Henry. Let me have my pen. Here, beta, H. Hertz in 1887. He performed the test on elements potassium, rubidium, and cesium. A question may be asked why. If this is the periodic table, children, then we know atomic size decreases like this and increases like this, और ये तीनों एलिमेंट्स यहाँ आते हैं. इसका मतलब दे आर द लार्जेस्ट एलिमेंट इन द पीरियोडिक टेबल. और एक लार्ज एटम होने की वजह से इमेजिन एक एटम ये है, इसका आउटर इलेक्ट्रॉन यहाँ है, और दूसरा एटम ये है, इसका आउटर इलेक्ट्रॉन यहाँ है. ये एटम ए है और ये एटम बी है. तो विच इलेक्ट्रॉन कैन बी रिमूव्ड इजीली फ्रॉम ए. So less amount of energy is required to remove the outer electron from these, or we can say they have a very low ionization enthalpy. Energy required to remove an electron from them is very less. Now when these were exposed to light of a minimum threshold frequency. Threshold means beyond this, below this, photoelectric effect cannot be seen. Electrons were ejected from their surface. Look, this is the diagram which we saw last time. I will just put my copy like this so that you can see it properly. Okay? ये diagram आपको बनाना आना चाहिए. ये देखो ध्यान से. This is the evacuated tube. In this evacuated glass tube, this is the metal, this is the detector. I haven't labeled it. ये detector है आपका, detector. And इसके बाद ये it is attached to an emitter and a positive, and metal is attached to negative. तो जब metal की surface से electrons are ejected, naturally they will move towards the positive detector. Now, suppose I am having energy only threshold frequency, then electron will be ejected, but they will not move because they have no energy. So my energy should always be higher, or the threshold frequency should always be higher, so that the electrons can move with that energy towards the positive electrode. So let us see now, what is threshold frequency? Threshold frequency is the minimum frequency. I'll just shift it here. It is the minimum frequency required by any element to show photoelectric effect. Now we know energy associated can be calculated by E is equal to h nu. यहाँ पे Planck's आ गया बीच में. उसने कहा मैं इस threshold frequency की energy निकालूंगा. And he said, अगर थ्रेशोल्ड फ्रीक्वेंसी ये है तो थ्रेशोल्ड एनर्जी ये होगी. बट ही गेव इट अ डिफरेंट नेम. ही सेड द एनर्जी विच इज रिक्वायर्ड, मिनिमम एनर्जी टू शो फोटोइलेक्ट्रिक इफेक्ट बाय एन एलिमेंट is called work function. What is it called? Work function. I have written it here. Okay, we go ahead. Suppose now a radiation is incident and it has an energy h nu. Then h nu should be more than h nu 0. Planck's constant की वैल्यू तो बढ़ नहीं सकती, पर nu 0 की वैल्यू तो बढ़ सकती है. Now to show photoelectric effect, nu should always be larger than nu 0. Now we arrive at an equation कि ये जो भी एनर्जी है इंसिडेंट रेडिएशन की, इंसिडेंट रेडिएशन है, इसकी एनर्जी है, it will be divided into two parts. Some of it will be absorbed by the metal as a threshold frequency to eject out electron, and another part of it, the remaining part of it, will be absorbed by the electron in the form of kinetic energy, with the help of which it can move ahead. Now kinetic energy has a formula half mv square. So this Planck's theory equation can be written as h nu is equal to h nu 0 plus half mv square. Now we can also write, suppose you are asked to find find what will be the formula of calculating the kinetic energy. तो हमें हमारे पास रिलेशन है h nu is equal to h nu 0 plus ke. अगर मुझे ke निकालना है तो ke will be equal to h nu minus h nu 0, or I can say ke can be equal to h into nu minus nu 0. So by using this formula मैं काइनेटिक एनर्जी ऑफ द इजेक्टेड इलेक्ट्रॉन भी निकाल सकती हूँ. This is where we finish with the photoelectric effect.